Welcome friend in our next topic, expression for the resultant resistance for series combination. Three resistors are given R1, R2, R3 with values, potential values V1, V2 and V3. They are connected with an electric circuit of V volt. Okay, current through the circuit is I. Here this statement is written as I have mentioned according to picture. Okay, so put your attention here. Let three resistors of values R1, R2 and R3 respectively connected together in series wise combination with an electric circuit with a source of V volt. What is the voltage of source? V volt. You know very well about the series combination of resistors, that potential across the ends of every resistor gets changed. So we have assumed here V1, V2 and V3 respectively. Suppose potential difference across resistors are V1, V2, V3 and current through the circuit VI. You know very well that in series wise combination the current is not going to change. Okay, so current is assumed I have mentioned here very clearly. Now by using Ohm's law, what does Ohm's law say? Ohm's law says that V is equal to IR. V is equal to IR. What is the voltage across the ends of the first resistor? V1. Resistance is R1 and the current through it I. So we have V1 is equal to IR1. That's why I have written here V1 is equal to IR1 and so on. V2 is equal to IR2, V3 is equal to IR3. Okay, since the current through every resistor is same I. On adding, V1 plus V2 plus V3 is equal to IR1 plus IR2 plus IR3. Okay. Since in series combination V1 plus V2 plus V3 is equal to V, so I have written here, I have also mentioned here in bracket, in series combination V is equal to V1 plus V2 plus V3. Okay, within a square bracket you should have mentioned the characteristics of series combination, what you are using. So I have written V is equal to IR1 plus IR2 plus IR3. Okay, first, and if the resultant resistance is on the place of these three resistors, we assume that there is a gross resistance with value R, which can take the place of these all three resistors. Okay, R, current is I, voltage is V. Then in simple way, V is equal to IR. Okay. Now using first and second equation, this will be second equation and this will be the first equation and this will be second. Now using first and second equation, we will have IR means this one is equal to this one. Left sides are equal, that's why right sides are equal. I will cut together on taking common I has taken n as common. I cut together, R is equal to R1 plus R2 plus R3. So on conclusion, I have written here, so we can say equivalent resistance is just sum of, this is just sum of all three resistors, values of all resistors if they are connected, means what they resistors are connected in series wise combination. Okay, got it. Okay, take a view and write it. Now we are going to get the expression for the resultant resistance for parallel combination of resistors. Okay, let three resistors in the same way that we have assumed in series wise case we will have assume the same parameters in parallel wise, but in the place of series wise I have written here parallel wise combination. Okay, with an electric circuit having a source of V volt. Same thing. Suppose current, keep in mind that here V was changing, V across the ends of each resistor was changing, but now current is going to be changed. Why? Because you know very well in parallel combination voltage remains same across the ends of every resistor, but current going to distributed among the resistors. So I have just assumed here I1 through R1 resistor, I2 through R2 and I3 through R3 resistor. Okay. In parallel wise combination, you know very well I is equal to I1 plus I2 plus I3. Okay, on using Ohm's law. Ohm's law, what is Ohm's law? Ohm's law is V is equal to IR. So we will have I is equal to V upon R. You can ask a question that I have here got the value of V1, V2, V3, but here I1, I2, I3. Why? Because I1, I2, I3 is changing there in parallel, but in series V1, V2 and V3 was going to change. Okay. So we will have I1 is equal to V upon R1, I2 is equal to V upon R2, I3 is equal to V upon R3 on adding together. I1, I2 and I3 sum is equal to this one. So on writing I in the place of I1 plus I2 plus I3 as per here. Okay, this will be the first equation. In the same way that in series wise combination we have assumed that if the value of resultant resistance be R, resistor be R, then the same on the place of these three resistors we are going to write here, we are going to put here a resistor with R resistance. Okay, because this one is equivalent for all three resistors. Okay, so we can write here I is equal to V upon R. Voltage across the ends of the resistor will be V. Okay, so on using equation first and second, equalizing first and second, we will have I left sides are equal, so right sides are will be also equal. V upon R is equal to V common 1 by R1, 1 by R2, 1 by R3. V will cut together. 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So as a conclusion, we have concluded here reciprocal of the resultant resistance in the sum is the sum of the reciprocal values of every resistor. Okay, each resistor in parallel combination. Is that clear? For your convenience, I am taking the camera near to the board so that you can see it very clearly. Okay. Thank you.